So hi, my name's David. This is buy, but also build, complementing security operations with in-house development. This is a talk you may or may not have known was going to happen right now. It's certainly not the talk I expected to be giving in this current moment, because back in August, I was told that this was going to be an alternate. So of course, as the responsible individual that I am, I didn't write it. They told me to be prepared, and so I was prepared to forget about it. And then, as of last Thursday, they come in and it's like, hey, we want you to speak on Sunday. You know you have your talk prepared, right? So I've spent the last 48 hours kind of putting together this talk. So I'd like to re-welcome you to Buy But Also Build, a talk written in 48 hours. So as I was putting this together, I was kind of thinking how I wanted to present my points in kind of a concise manner to kind of get across sort of the bigger ideas I wanted to highlight. And something that my friends and I kind of enjoy doing in our free time is giving hot takes on things. So my definition of a hot take is sort of it's expressing an idea respectfully in sort of a kind of direct manner, and then being able to follow that up with lively discussion on random topics. So we've talked about things as like, oh, is a hot dog a sandwich? What is the best way to create s'mores? That sort of thing. Surprisingly, Google has a definition on hot takes. I prefer that they draw attention to a topic instead of attracting attention to something. So I would like to rename my talk again to Hot Takes, somewhat related to Buy But Also Build, a talk written in 48 hours. So some disclaimers ahead of time. Nothing I talk about in this talk is reflective of my prior and future employers. Purely anecdotal, things that have been kind of bubbling up in my mind over the past couple of years as I've been working in InfoSec. And anything I say about security products, like take it with a grain of salt. I still love them. They serve a very good purpose. Some of them are great. Others, they're okay. But in the end, like in general, you do need security products. You can't just build everything yourself. So with that said, who's this crazy guy up here? My name's David. I'm an undergraduate senior at George Mason University. I'm studying cybersecurity, bachelor's of science. It's kind of a new degree, a few years old. Generally, we focus on like looking at systems from different perspectives, like, oh, let's take a networking course, like a cryptography course. I'm kind of deep diving how security plays a role into that. So that's how I've got my introduction into security with school. Outside of school, I'm the president of Student and Community and Technology. We basically build open source software for the GMU community, by the GMU community. Generally revolving around web apps. So that's how I got my interest in building things, is from that organization. I've also interned for every summer that I've been in school. The past two, I've been on an InfoSec team at a large media company. And generally, kind of like my quick pitch as to my interests is I'm very interested in building out systems that mitigate different vectors based on prior mistakes that we've made as an organization, and then automating a solution to that at scale to the point where you can't really prevent something from happening again, but you can get it to the point where you're like 90% sure that you'll be able to detect it if that vector comes back again. So I'd like to give 3 hot takes in this talk, and in the second one, I'm going to focus on 2 case studies related to building your own solution in lieu of buying one. And then there's going to be a Q&A in the end where you can roast me for anything that I say. So hot take 1, security is an unsolvable problem. I think this is kind of something that's been widely acknowledged, but not really stated by people. We're never, ever going to solve security. It's going to be a constantly evolving thing based on new vectors that come out, new techniques, new ways of mitigation. And I feel like that sets a very important baseline for discussing new approaches to kind of handling the problem that can never be solved. Because security is an unsolvable problem, though, it's generally seen traditionally in organizations as sort of a tax. You know, C-level execs, they just have to give some amount of money to security teams so they can mostly avoid something bad happening, you know, the sort of drill. Over the past decade or so, and this is just an anecdotal point, I believe that the amount of resources going into InfoSec teams has greatly increased. And that's mostly due to high-profile breaches, such as like your Targets or your Equifax or your Sonys. And so because of those increased resources, you end up with teams having more options on what to do. Whereas traditionally, you just try and get as much information as possible, try to, you know, use traditional methods to detect things. Now we can try and be a little experimental. But as the old saying goes, more money, more problems. The general easy, I don't want to say easy, but like the quickest way to kind of ramp up security operations is to buy more security products, because you have like little problems in your organization that you could address if you threw more people at it. But you know, there's this really neat product that might come in and not solve your problem, but get maybe 70% of the way there, which is generally good enough. And then when you purchase these products, you generally try and min-max them to work as intended and maybe even more. And this kind of works to a degree. And I'd like to kind of dive in on that min-maxing. So the way I've seen organizations go when they purchase these products is you generally fall into this cycle where you're rejigging existing infrastructure to support a new product. So you've got another damn agent to deploy onto every machine in your entire network, or some like SSH key needs to be placed on every single server. Oh, wow. Some SSH key needs to be added to every single server in your entire AWS environment, and nobody adds it. Let's say you buy a new box and need to reroute all of your network traffic to that box so it can, you know, decrypt it and then re-encrypt it and go out the other side, and nobody can configure it correctly. So you're spending like, it should be like a couple of weeks, but it ends up being a couple months trying to get it to work in the first place. And then you end up stretching the product to do things they may not have been designed to do. So I've been in situations where we've had to like go into admin interfaces and scrape like little bits of data in like an HTML table, rip that out, and be able to like parse that into useful information because it's not exposed anywhere. Or you've got like undocumented or deprecated API calls that you're using in prod, because of course you are. And then if those two, you know, don't work, or you kind of throw as much resources as you can at it, you end up calling support or purchasing professional services to come in and pretty much beg them to add new functionality or make you think that it works the way it's supposed to do. In my opinion, this cycle leads to a dangerous time waste. Sure, it can work in some situations, but in general, you're just spinning your wheels every time you add something else and you're really only getting 70% better if you can min-max it all the way. And there's also a non-trivial risk that you don't even use the product. I think every organization has something that they've purchased for thousands of dollars and that they've never used. It just in general, like, it can work, but there's a dangerous kind of slippery slope you can go down where it doesn't work. So I like to kind of jump off of that to my second hot take, which is that buying security products will never fully address your organization's security problems. And I'd like to bring up a couple of examples to kind of hone this in. So incident response to a previously unknown vector. I've seen security products fail when this happens. So let's say some O-Day comes out, or Brian Krebs puts an article out about your organization, and you need to very quickly figure out what's been affected, how long has those assets been infected, how can you resolve this incident that's just all of a sudden come up. Generally, the security products will fall to their knees, like they don't work for very rapid things. I've seen them work well in long-term sort of things, but you're really only getting 70%. If you have legacy systems or strange architecture implementations, for example, I've seen some subnetting setups where every floor of a building is its own subnet. So when people walk up and down the floors, they're given new IP addresses every single time. And so you just end up with like one person owning 100 devices just because they keep going up and down the floor. Or like IoT vending machines, because of course you have IoT vending machines. Those things products don't really work well on because they assume a generally perfect setup. And then also the ad hoc answering of questions. So like, oh, do we have any Windows 98 machines still around? The answer is always yes. I've seen you never get full coverage with any of the products that you buy. You get like I said, 70%. And then the kind of edge cases or niche problems, they don't really do a good job of addressing. And so this is where I'd like to present the idea of solving your own problems. Per organization, you're going to have weird edge case niche scenarios. And the only people that can really solve those are the people who know know those problems the best. And generally that ends up being you. You can try and call consulting people to come in or, I don't know, buy more products, but in the end, you're the only person who knows why this niche problem exists and maybe a way to attack it. And the way you kind of solve your own problem is you want to complement the existing workflow so that they do not become a disruption. It's very easy to just like, oh, I'm going to build 100 tools and it's going to cover everything that our products don't address. Then you deploy them and then you instantly forget about them because they don't integrate well with what currently exists. They don't complement what's there. They disrupt what's going on because people have to like, oh, what was that like? What was the URL to go to that new service, or what's the API call I need to make? You really need to work in tandem. The operations team needs to work in tandem with whoever is building out a new security service internally. And it's an org by org basis on where you find that balance between functionality and disruption. I can't really tell you how to do it. It's really up to how your organization is currently set up or managed. So I'd like to do 2 case studies on organizations who have implemented solving their own solutions. And what's interesting is that these organizations, or at least the high profile ones that I'm familiar with, have been done by younger tech-focused companies who have a lot of talent in building out large-scale applications. And so they've kind of started to merge those type of minds with their security operations teams. So I'm going to talk about Netflix with Stethoscope, which is more of a compliance sort of project, and then Airbnb with Binary Alert, which is more of an operations sort of project. So with Netflix, they had a problem where they purchased these endpoint protection suites to put on everybody's laptops, to scan for antivirus, that sort of thing. And the problem is these suites generally yell at users when they do something wrong, and users ignore those yellings. I mean, if you see like 50 dialog boxes come up saying, oh, you got to delete this file or you got to move it, people are just going to hit cancel because they don't have time for that. And it ends up being information overload, these programs that I've seen in general. There's no feedback loop to kind of encourage them to keep using the products. So you have it on everyone's machines, but they're effectively not being utilized in a proper manner. So their solution to this was to pretty much pull out as much data as possible from those suites that they purchased and build a kind of friendlier interface for users to actually use the products in the first place. There's a quote here I pulled from their blog post where they talk about how designing this interface with focused actionable information led to a more secure state within their system. And there's an image there. The general idea is that like whenever you get a laptop from Netflix as a new hire, Stethoscope is loaded onto there, and all of the products that they purchased would get added into the interface. And instead of yelling at you when something's wrong, it would teach you how you can actually get that done correctly. Kind of a show don't tell sort of mindset. And so I'd like to highlight this because it complemented their existing products by ensuring that they get used by their users in the manner that they should be used. So sort of correcting a fault with the products that they purchased. In a traditional organization, you might go to the AV vendors, be like, hey, can you change your boxes to be different? But they don't do that. So being able to roll this out within a couple of months, they were able to get to a more secure state. Airbnb, they had a different problem where they needed a very specific tool to scan binaries against YARA rules that they've developed internally or open source YARA rules. Specifically, it needed to be private and low cost, something that could just scale out horizontally for whatever they needed. VirusTotal does this, but it's a public service, and due to certain business requirements that they don't really state in their blog post, they couldn't send it out to the internet. You can probably take a guess as to why. So they built it. They utilized pretty much a bunch of AWS services, tied them all together, and spun up a security service API that people can submit binaries to, scans them against YARA rules, and was able to integrate that workflow, the results from that program, into their security operations response. So in the diagram, they just say they just use SNS alerts. But I think this is a really good example of sort of a plug-and-play solution where you have one or two people build out very quickly or being able to rapidly iterate and deploy an application that integrates with their security operations team such that it can get used at scale. And I just wanted to throw in, like, I think Lambdas is probably like one of the biggest things to happen to security operations teams because you can very rapidly build out a service like this for these niche edge cases that may not be offered by traditional vendors. So 3 big takeaways from these 2 case studies. High ownership of the software that you build leads to effective software design. So you don't have to add in lots of features. You don't need to factor in lots of weird user stories. You have one thing you needed to do, and you needed to do it really well. And so because you know exactly what you need to build, and you have the high ownership of it, you can deploy it, and it'll hopefully integrate well with your security workflow. A lot of people don't realize, though, that there's a higher upfront engineering cost when you're building these things, obviously. You're having to dedicate time and resources away from responding to incidents to building out these tools. But I believe they reap in long-term benefits, and I'm going to return to this point later. And something interesting about both these projects is that they open sourced. And I'd like to make a 2.5 here, is that open source is the only way to ensure the long-term success of an in-house developed application. I'm not going to go into a Richard Stallman diatribe here, but I just really want to highlight the benefits of open sourcing your in-house application. And functionally, the collaboration aspect is probably the biggest thing that you gain from open sourcing your application. You're not the only one with this problem. No matter how weird you think your IoT vending machines are, someone else has an even worse setup of IoT vending machines. And you benefit from any functionality that people either add to your repo, or if they fork your repo, you can kind of pull in any changes that you need. It also encourages you to not cut corners or be negligent with your code. I've seen a lot of applications be built in-house, deployed, and then completely forgotten about. Or there's like hard-coded keys everywhere, and it's just a mess. By open sourcing it, it forces you to build an effective program that can not only be used by you, but be picked up and plopped into other people's organizations. And I think this is a benefit that now other people realize when you take it open source. There's also an idea of strategic altruism, which is a term I made up, but is something that is becoming increasingly popular with companies, where they open source all the things to gain sort of goodwill from the people. So Microsoft is in the process of doing that right now, where they open source pretty much everything that they do to gain kind of developer trust and stuff. So your organization will be highlighted more, in a sense, if you start open sourcing all the things. That's just something I want to add. So last hot take. It is necessary for operations teams to begin taking ownership of the issues not covered by their security products. In my opinion, it's dangerous if you ignore the 30% that isn't covered by your vendors, or you try to stretch the vendored products to cover maybe not what they don't originally cover. It's not a sustainable solution. It's going to bite you in the butt at some point, and I've seen it happen at organizations. And I feel like taking the time to engineer a few things here and there is, in the long run, going to be a benefit for you, and ensuring that it complements your existing workflow, again, is better than not having it at all. You can't engineer everything yourself. Obviously, no one's going to rebuild AV. No one's going to be building their own WAF. You're going to be buying those, but you should know when those products fail you and where you can kind of build in a complement to cover up whatever 30% they don't cover in the first place. So in real life, at scale implementations of this, I see DevSecOps being the biggest sort of movement in people building their own in-house applications. It's, in my opinion, the most mature subset. They kind of take it to the extreme where everything is done in the cloud, everything is done on Lambdas, but I think it's a good kind of reference point for what I'm speaking on. There's this great book that just came out called Securing DevOps. I really recommend checking it out if you're interested in this topic. They basically stepped through building out, piecemeal security services, security service APIs, and how they integrate in with your workflow. And there's a talk right after this one on DevSecOps, so you should stick around if you're interested. Another example I can point to is I was recently talking with an organization, and they spoke on how they do 40-40-20 time with regard to their security operations, where 40% of your time is responding to incidents, resolving issues that have come up, your kind of standard practice operations day-to-day workflow. But then the other 40% of your time is spent automating what you just spent 40% of your time doing so that they don't happen again. I think that's a really interesting way of dividing time. And then 20% is how you divvy it up between the 40-40. So if you need more time to respond to incidents, you plop it there. If you have more time to automate what you were just doing, you can put it there. It's sort of a flexible way of dividing up your time so that not all of your resources are going to building stuff and not all of your resources are going to responding to incidents all the time. I think it's a good balance. It's not all roses and sunshine, though. As I mentioned a few times, you should be asking yourself a few questions, like, do you have the resources to build out an adequate solution right now? Manpower is probably the biggest thing. If you're on a team with like 4 or 5 people, it's probably not the smartest idea to dedicate 2 of them away to build out some service really quickly when you need to be continually running your operations on a day-to-day flow. So maybe you want to bring on a new hire. Maybe you want to reach out to another team, see if they can help you out. Also, compute's becoming less of an issue of organizations who move into like ABS and stuff, but it's still in some cases like, oh, I need to manage my infrastructure to deploy things onto, like, do I have time to manage that compute? Would the development of this application result in null effect on your operations? Like, are you just like spinning your wheels? Like, will this only help like 1 or 2 times, or will this help every single day? If you end up building things over and over that have null effect, you're just wasting time. And then can you ensure that this will be maintained over time, adding new features, fixing bugs, that sort of thing? Open source is a great way to ensure this, but if you want to keep it internal, you should have like 1 or 2 people who are pretty knowledgeable about the project, being able to pass that knowledge along to others. And don't repeat yourself. Don't rebuild what you're already using. Only add on to things that you've already purchased or practices that you're already doing. The biggest thing here is just don't waste time. So that's all I really have. Like I said, I wrote this in 48 hours. I'd like to open the floor to any questions that you might have, and thank you for coming out. Yes. Yeah.
Are there any red flags or yellow flags that you should be looking for that might indicate that you should build it yourself, since you said you know the ins and outs?
Yeah.
Any red or yellow flags when you're looking at potential sales pitches on the projects or trials?
Yeah. I think the biggest thing I've noticed when vendors have come to my team, for example, trying to sell products, is just like over-promising the world and moon. You know, our product will cover everything. You should always have a healthy dose of skepticism. In general, as long as it covers 70% of your use case, I would still recommend buying, because you do have some sort of guarantee, some sort of contract with them that it'll work in some sort of manner that will help you. What I'm really advocating with building yourself is covering up the holes that they ignore or they don't do as well. I don't believe that building everything out yourself is either a sustainable solution. It's sort of a balance that you need to maintain, and it's really up to you and your organization on where you draw the balance there.
Easiest question.
Yeah.
Who was the author for the book?
Oh, yeah, I believe it was Julian. Yeah, Julian Vehent, Julienvehent. This just came out, and it's great. I love it. Yeah. Yeah.
Do you have recommendations for maybe when you switch from firefighting to building some of these tools? You know, manpower is really one of the most constraining factors. But that's sort of a tough line to know when we should start building these tools, because we still have things coming in.
Yeah. No, I think part of it is like a feel where you know that something like your current practice for handling a vector that has come in is inefficient. Like everybody on your team kind of agrees that this is stupid, we should do something about it. But also, like I said, you need to know when it's a good time to start investing resources. So it's a very org by org basis, like I said, and I think it's nice to have like 1 or 2 people on your team who are traditional software developers who have come into security. I've seen roles on teams of like people who are software developers be like code review people or like that sort of thing. You can kind of move those resources around to, hey, can you build this out in a week? Prototype it, maybe get it deployed, and then we can iterate on it as we need to. But it's very situational. The only thing I could say is I would never stop what you're doing to build something out. It should happen in parallel. So. Okay, I'll leave you all to the rest of your afternoon. Thank you.